Hello everyone, welcome to today's stream. Just give you a few seconds in case you're just arriving, and then I will go through what we're going to be doing today. So, let's just wait for people to arrive first, and then we can talk about the cool stuff that I wrote in the title, so Uber. Just going to check the volume here. All right. Just going to add a little bit of boost. Boost is always good, right? So this should be a lot better now. All right, team. So I can see Sad Salami Rose, you're in the chat. What are you up to today? Are you here for the first time? I don't think I've seen you here before. So without revealing too much of what I have planned, because I have planned some things. Good to see you first time here. Thanks for joining the stream today. I do like to interact with chat, so do ask questions if you want to know more. But I'm just going to start off by saying what we're going to start with today. So we are going to work with a data set from Uber. It was actually obtained from a Freedom of Information request that the US operates under. I'm not so familiar with how that works, but basically you can request certain data from authorities in the US that then ask companies to give out that data, something like this. If you know more about that, you can feel free to correct me. But basically it means that companies need to provide data about activities. And one of these foils was done in 2014, I believe 2015. Maybe there was a second request, I don't remember exactly. And basically what happened was Uber provided data about pickups in New York City. And actually this data has been consistently provided now by all the ride-sharing companies. There's even a dashboard that you can find on that. And Oompa Loompa, how does one become a coding god? Well, I wouldn't know because I'm not a coding god myself. But I think depending on what you're trying to code, you can definitely just practice. I think it's just a lot of practice and learning for what purpose you're trying to code something, whether it's game development, whether it's development of, in this case. Yeah, unfortunately there is still a lot of people confusing Sweden with Switzerland. It doesn't help that I believe a few years back the New York Stock Exchange raised the Swiss flag, or was it the Swedish flag, instead of one of the other by mistake. So yeah, things like that don't help too much. I used to when I was like 8. Good to see that you're past that now. I assume you're not 8 anymore if you're on Twitch. Although this is not a mature stream, so you're definitely allowed to watch this if you're 8. I don't know how much you would understand, but so moving on from foils and Switzerland versus Sweden discussions, we are going to run some queries against this Uber dataset today. I already took the liberty of importing it because that's pretty boring. Congratulations on your 8.1 birthday, Oompa Loompa. And this Uber dataset has some interesting information in it. I was going to also perhaps attach some additional data into the Uber dataset. like maybe weather data, for example, based on lat/lon, because our data set does have latitude, longitude in it. However, someone actually beat me to the punch, Todd. So he actually has a very cool setup here. I can just show you that, what he's done. So he made a very detailed post about this Uber data set. And he's gone a lot further because there's actually a live dashboard available of ride-hailing and taxi usage in New York City. So I'm not going to be able to reach this level today, just to be very clear with you. But I do see what kind of things are possible having this kind of data set. And I thought it would just be interesting to play with something that's not COVID data. I'm not going to rant about COVID data anymore, because I got a little bit upset about that. Last time looking at all this COVID data was a bit gloomy. But this time we're just going to concentrate on the Uber data set. So yeah, he beat me to the punch on that one. Which month is it? 1 out of 10 out of like 12. Yeah, I don't want to I don't want to go too businessy for you, Oompa Loompa. So basically, this is the data that we're working with. So we're working actually trip data from 2014. So yeah, it is a bit old. It doesn't mean that we can't draw any conclusions from it or something like that. It just means that it is 6, almost 7 years old. So we do have to bear that in mind when we do this kind of analysis. So the description was as follows. I actually obtained this data from GitHub. So Oompa, you're asking, wait, why exactly are you looking at Uber trip data from 2014? Well, I thought it would be fun to just look at this data set to see if there's anything interesting that I can find. And at the same time, it's a way for me to show people who are watching how SQL works. And if you do reach a certain limit with SQL, you can also visualize the data directly using something like Metabase, which I have up and running as well, which I'll be showing today as well. So you can actually plot all the lat/long locations automatically using this kind of software, which saves you from doing that step, let's say manually in your BI tool or your some kind of visualization tool that you're using. You are our computer sciences teacher's expectations. Well, I try to keep the material interesting because it's also for myself. I mean, I wouldn't want to look at something boring and analyze that because I wouldn't find it very exciting. Yeah, there's a lot of geniuses around these days, which is pretty impressive. With like sort of cybersecurity stuff, I'm not that up to date. But I've protected my accounts sufficiently, I'm happy to say. So yeah, what kind of data do we get from this? Actually, it was Kaggle. Sorry, I did say GitHub before. I meant Kaggle. And basically, we got because of this foil, they uploaded it to Kaggle so that a lot of people could play with it. Oh, hi, Sharpclaw. Nice to see you here. Oh, the stream is growing. That's very nice to see. I'm very happy when people tune in and have questions, or if they are just, saying interesting things. Oompa Loompa, it's so disappointing when I find people my age that are like 10 times better at me than something. You know, there'll always be people that are better than you at something, but it's about finding the thing that really clicks for you and is ultimately really enjoyable for you. I mean, I really enjoy doing this. There's plenty of people on the planet that are better at data science or SQL than I am, but I know that I am capable of doing this and it's fun for me, and if other people get enjoyment out of it, that's great. And if not, that's no problem. I'm still having fun, which is why, I'm not streaming for professional reasons. I'm just streaming because I'm going to do this and spend some time doing this, so why not share it with the world and interact with people at the same time? So yeah, we are looking at Uber trip data today because I didn't want to look at COVID data again. Maybe we'll get some cool vaccination data or something in like 3 or 4 months. So we got 6 files, which is coincidentally 6 months. Well, it's not coincidence. They did it that way. And basically they have 4 columns. And maybe at this point you're thinking, well, 4 columns, that's not a lot of information. It's actually really interesting. So there's a date time of the pickup. Let's be careful about that. This is not the drop-off. This is just the pickup. And that's quite important that they didn't provide the drop-off, because for privacy reasons, otherwise you could plot each route. And I think that could be pretty dangerous. My parents weren't peacefully divorced and I couldn't between my dads. Well, you know, you can make money playing games as shown by esports. Do I take notes in coding platforms? Well, yes and no. I mean, this is just Sublime Text. It's just a nice little text editor that I use for just noting down. Like today, what I'm doing in the stream. Otherwise, I just take notes in things like Trello and things like that. I'm trilingual actually, but if you're bilingual, that's fantastic. What's your other language, Oompa? So, the pickup, it's the drop-off location is not provided in the data, which is good for privacy reasons, because it means that we can't follow the routes that people took, which could be quite dangerous, I think, for privacy reasons, because you could start to plot which drivers drive which route and all this kind of stuff. Lat lon, so the exact location of where the pickup was. So date time, lat lon. And this base code, TLC base code, it just means it's like a sort of base station thing. But yeah, let's put that away and look at the data itself. So I did activate a new color theme today. I checked it with my partner, and she thinks it's also very nice. So let me know if you like this theme. It's called Material Pale Night. It's part of the material design package for Data Grip. It's free, so I do recommend that because it makes everything look quite nice. So this is one of the example or one of the data sets that we got from one of the months. So this is April. So this is what it looks like. We have a date time, we have a lat, we have a lon, and we have a base code. And you see these base codes correspond to just some internal Uber base code that they have. And it's kind of interesting because probably if we had more information about the base codes, we could do really cool stuff. But of course, Uber is not willing to provide us all the information about the base code. I mean, this would make kind of their whole business analytics possible. If you found out, which rides are being hailed from which base or whatever they want to call it. So, I definitely. Oh, and that kid who was a cybersecurity expert at 12 was offered a job by the government in the 6th grade. Yeah, I wasn't offered any jobs in the 6th grade beyond distributing mail, I believe it was. So yeah, I did it on rollerblades, so it was a bit faster. So the first thing we need to figure out is let's start doing some basic QA. What do I mean by QA? I mean quality assurance. We have to start figuring out if the data that we have is actually legit. I mean legit. It's the data that we got. We can't really check whether it's real or not, but we can check consistency of it. Right? We can do some sanity checks on it. Now we have months and months of data, and the first thing I would like to do is actually put them all together. Now, I deliberately imported them into separate tables. If you were smart, which I'm maybe, I don't know, I could be smart, but I could have imported them into one table because they all have the same format. But I chose to do it in separate tables to show how I would join these together if I did have tables separated by month, which hopefully you do not, because it's a bit annoying. And we're going to use a common table expression to do this. Common table expression just means we make basically windows, or we make kind of separate data frames for things that we need, and then we can always access them within the same query. So we don't have to create a table and then update that table first. We can kind of do everything within the same query. So the simplest way to explain that is just to show what I want to do. So I want to make like my base data frame. I'm just going to call it data frame. You can call it anything you want. And my base data frame is going to be this, which is my select statement, which I will work on in a second, but I'm just going to finish off the formatting here. And so what I'm going to do then is basically, this is my common table expression, my CTE, where I have this windowed function in here, which gets me my data that I need, and then I select from it. So when I run this whole thing, it gives me, my whole data set. Now, let's work on getting the data we actually need in here. So none of our tables are actually what we would consider a master. Normally, if I would want to work with a data set, I would want to have one table, which is kind of the master, and then I would start joining all the tables onto that one using, for example, left joins. Now, all of these months are equally important. So we're just going to give these a basic alias. I'm just going to use the 3-letter month codes as the alias, because using numbers is pretty much taboo. It's probably possible. No, it's not even possible. I've never done it. So I would just use these aliases. I'm going to write the aliases out with the AS just so people can follow. You don't need to do it, but it does look a bit nicer. So I'm going to use the 3-letter month codes for my aliases, because it makes it easier to then write the queries. For example, April.base, right? Then I know this is from April, and I don't need to think, okay, A, B, C, D, that's the 4th month, which is then July in my data set. So I'm going to use these, and I think that's a good solution. And what I'm going to do is I'm actually, instead of a left join, I'm just going to join everything onto this. So DataGrip is trying to suggest something for me. I don't know if you saw that. I'm going to do it again. If I do Uber here, it actually gives me like a suggestion of what to join on. And this is kind of interesting because I technically don't have the right information to join. Because I don't know if the bases from April are also the bases in May, who are also the bases in June, etc. I actually just want to join these together. And I don't want to use any keys. Unfortunately, that's not really possible unless I use union. And I'm not so convinced that I want to do it with union. I need to think about that for a moment, about whether I want to use union for this. Let's do some sanity checks before we decide here. So we're going to do some dirty coding in lowercase, I know. So I want to find out more about this base. I'm going to find out how many bases there are in this data set, at least in April. So I have 5 bases that have all the values assigned to it. Now what happens if I change this to 5? Okay. So it seems like these base numbers are actually the same throughout all the months. And we are extremely lucky if that's the case. Wow, okay. So we are quite lucky because all of these bases are the same throughout these throughout these 6 files. So I've gotten extremely lucky here. Otherwise I would have probably needed to just union them in the end, because I just needed to sort of insert them together. But fortunately that's not necessary. So we are going to go with a simple join. Uber 2014-05, so this is May. We're going to join May's base to April's base. Voila. And now we're just going to repeat this process for each of the data sets. Unfortunately, data group is not smart enough to recommend my formatting for each one, which is unfortunate, but that's the way it is. We need another one here. Join. So this is July. July dot base is April dot. And you'll notice I'm joining, rather than joining from the previous onto the previous one, I'm actually joining them all onto this April set. It doesn't really make a difference. It is the same thing in the end. So yeah, you can do it anyway, but I'm just doing it this way. I prefer doing it this way. I can't really answer why. I don't really have a good reason for that. But that's the way I do it. Maybe it's just the way I learned it. August, now we just have September to do. And now we should have that joined together. So if I do this, you see what's happened here is we actually have all the data sets joined together on this key. Now maybe this isn't the best way to analyze this data set. The reason being, the main issue here is that now we have created a kind of frame which is actually, let's call it base object. Because we are now sort of viewing the data as from a base-centered approach. We're not doing it from a date-time centered approach, which has good and bad sides. I mean, in this particular scenario, it probably doesn't hurt us, but if we just wanted to have one long basic data set with just all the dates, we would need to union, because that would actually put this data set, so the second one here from May. We'll get to the date formatting in a moment. This is the US formatting, which yeah, not happy about. This would actually be underneath, so basically continuation in rows. And right now we have basically every base has kind of multiple rows where the base matched with all of the columns that matched it. So I'm not super happy with that. I think it is probably a bit unnecessary. We could think about doing it as a union instead. That might be better. My puny brain needs to process this for a moment and think about it while my query is running. We could do a union instead. the nice thing about union is it takes out duplicate rows, which we don't have in our case, but it is very very cool function. So this is still running, and I assume that it's having some issue here because of the size of the data set. I didn't mention this before, but each of these tables is actually kind of big. So each of them has something like 500,000 rows. I mean, big. This is, you know, I don't know if you would call this big data, but yeah, this is because I stopped the query. It's a little bit, I didn't really like the color coding of that error, but I suppose, yeah, if an error comes up, you should see it. Now, I think in this case, we can think about just maybe doing a union instead. I just want to see if it's having trouble with 6 joins, or if fundamentally I need to allocate more memory or something like that. I didn't mention it today, but I did in the last stream, maybe just for posterity reasons, or for completionist reasons. I am running Postgres on my local machine in a Docker instance, and I've given it as much memory and space as I can. I have a pretty decent MacBook Pro, but it does sometimes have issues with larger data sets like this one, where it does take some time for the query to complete. You can install Postgres also directly, but I like Dockerizing it because when I don't need it anymore, I just close it, and the data is gone. Of course, if you don't attach the if you don't attach it to a what do they call it? Forget the name. Basically, like an attached data source in your machine. So it is having actually trouble with the join. So it probably would make sense to just union them. So let's move away from that, because I think it's going to be easier. I'm not so interested in the base, as I said before. We don't have any other information about the base, so it's not like it's going to help us to have everything oriented by base in the first place. So actually, we're just going to basically scrap this. Well, I'll keep it there just for the moment, in case we decide for some reason we don't want to do that. So this is the union expression, and we can just select from Uber blah 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 14. Let's call this April. Union, select everything from Uber May. That's it. And I mean, basically just puts them on top of one another. So if I go all the way here, and then I go to the end, you can see here it just sort of overlaps. Now, is the data sorted and stuff like that? We will get to that. As I said, I want to do some QA on this to figure out if stuff is okay. I mean, how the data looks like. But we are going to continue this common table expression. So we're going to call this base data now, because that's the lovely name I've chosen for this. And we are going to just do everything as a union, and then we don't need to worry too much about issues of joins. Basically, we know that they have the same composition, so the tables are composed in the same manner. So you have to excuse my live coding. I'm not used to really explaining my code as I go along, So I sometimes just stop talking for a few seconds. And if that's the case, if it's too silent, then just yell at me in chat. And I mean all caps yelling. So where are we now? June. So now we got to do July. I think that union all would be possible here. I need to check that because I've actually never used. Must have same number of fields, which we do. Oh yeah, we could do it that way. That's actually much more efficient. Let's try that. So instead of writing them like this, we can write like this. I believe. Oh, it doesn't like that. Ooh, do I even need to union them? This is actually a good question. What happens if we just select without the union? Oh yeah, you see it's just putting them underneath each other. Okay, so we'll just do it like this. I guess this is one way of doing it. Uber 6, 7, 8. So I don't know if this works. Oh yeah, of course. It doesn't like. That's unfortunate. It doesn't like the fact that I have. But then I could just equal them out, maybe? I have different numbers of columns. Yeah, and then we arrive at the same issue that we had before with yeah, this is the same issue that we had before. So if we join or if we union with multiple selects, then we end up with this data frame being more columns, which we don't want. We want actually all the data to be directly underneath. So we're going to do, I would say, the classic the classic way, which is the long way around in this case. This is annoying me. I have to put this down here. There we go. From Uber 20, come on, there we go. Union, select everything from 9. So now we have, if we just make this a t-bit smaller, this is our base data set. Everything is now joined together in one ginormous table. And we should have, basically, if I click this, it does a count of my entire data frame that's in here, that's loaded. And I'm working with this kind of in memory. So there's definitely some benefits to now loading this back into a full table, which I might do. So this is 4.4 million. So we actually, because I'm working with this in memory, we actually are going to load this back into a table. And this is the really cool thing about data grip. I don't know if other tools have this, but I can just go here to my Postgres and say in my public schema, so here, this one, this is my target. And I'm going to call this Uber 2014 0409. R209. I don't know how long this is going to take. 4.4 million. So it's importing. In the meantime, I'd love to know where people are chiming in from today. I can see there's 6 people watching at the moment. That's pretty cool. I was saying the other day I'd be happy to get 1 or 2 viewers for this kind of stuff. It's not exactly the most exciting thing on Twitch, probably, for a larger audience, but so this is going to take, let's see. Yeah, it's going pretty quick. We're just going to wait for this to complete. The reason I'm doing that is because otherwise, working with 4.4 million rows in memory, what's going to happen is every time I execute this entire query, so whatever I do now, if I do like select, I don't know, base, then some counts or whatever, as soon as I do that, it's going to work with these 4.4 million rows in memory every time. I can't limit it in any way. Whereas if I have a table here, this 04 to 09 table, I can limit it by using a where. Where, for example, base, I don't know, like, who knows, 02 or something. I need background music. You know, I don't want to impose Sharpclaw. I don't want to impose background music on anybody. So everyone is free to play the music they want in the background. But I will take that suggestion for next stream that we add background music. Definitely. I will save that video for next time. Oh, yeah, that's a good one. Definitely gonna, I'll save that for next time. But for today, I don't have it set up that I would not burst your eardrums by suddenly playing YouTube in the background. But I can get that set up for next time for sure. It's true that people have different musical tastes, but I guess playing something sort of generic in the background. I mean, Twitch has this sort of soapbox or something like that. I can't remember what it's called. Could be possible to use that. Yeah, no, I was reading about like all these DMCA claims and things like that. Yeah, what I was saying here with this kind of query is that if I do something like this with the 4.4 million rows in memory, then my computer is just going to scream every time. It's just going to take too much time to process. So it definitely makes sense to just put this into a table because I have the space. I mean, it's not a storage problem for those couple million rows. And yeah, I think it's kind of a funny thing. Like, I don't know, even just maybe 6 or 7 years ago, it wasn't feasible to work locally with these massive kind of data sets. I mean, importing these kind of like 4 million rows into some local database was just out of the question. But these days, with any decent computer, I mean, even with like a MacBook Air, this would be possible. I mean, I have Pro for a lot more memory that I don't run out locally, and doing things like this are quite intensive. But it's pretty impressive when you think about it. So yeah. So while we're waiting for this to import, I will start constructing what I want to have. So we don't need the common table expression anymore, necessarily. We might go back to a CT later. But we can just pop this over here for the moment. What are we going to do? We are going to select everything from Uber 04 to 09. We're going to call this just Uber full. Oh yeah, I mean table aliases, I could debate for years. I mean, I know people that just call them T, for example, or T1. And I mean, for me personally, when I'm selecting data from multiple tables and I just have like T1.base, and I don't remember what table is what, I find it pretty confusing. So I actually prefer just using some kind of sensible name. So in this case, for example, I'm going to call this uber full. It's probably, probably not going to be joining it to any other data. So I could of course just call it, U or something like that for now. But I just in terms of preference, yeah. So I'm just gonna take a drink here quickly. All right, so what do we want to do? We want to check consistency. These are the QA checks that we were talking about before. We need to figure out if this data is what we expect it to be. So I know I have 4 columns. So if I just start with my basic check. Okay, what do we have here? I'm going to make this a little bit bigger. So I've got date, time, lat, lon, base. These are my 4 columns. Where do we go from here? First check is how many rows do we have? This is very easy with Postgres. You can just do count 1. You get a row count. Now what I like to do, this is just my personal preference, is I actually write this stuff down. So Oompa, you were asking me before if I write notes in coding. Yes, in this case, I am noting down something I need or want to write down for later directly in my editor. I probably won't save this outside here. I just need it for the moment. But if I was doing some kind of detailed analysis, I would definitely want to document this in addition to my analysis and say, okay, this is how many rows we had initially. This is how many rows I had to throw away for whatever reason. And yeah, so that's the first check, is how many rows do we have. Now comes the fun part. We don't have any IDs. So normally I would count like the number of rows, and then I would go and count like a distinct ID, for example. But we don't have an ID. We don't actually have an identifier because we're working with time series data. So what I'm going to do instead is I'm going to use, I just want to find out how many bases are here, right? And I want to know especially how many rows are there per base. So we have 5 bases. All right. Now how many rows do we have per base? Very easy. We can actually just do count 1, and in front of it we're just going to write base. And a lot of people are going to get angry now, or not, I don't know, maybe only half the chat. We have trailing comma, not a leading comma. So leading comma would be here on this line. And a good colleague of mine from work, he actually uses leading commas, and we kind of debated this the other day, and there's all these articles all over the place about, oh, leading commas are better than trailing commas for this and this reason, because you can, comment it out and you don't have to worry and blah, blah, blah. And there's all these reasons, but what I can tell you is, honestly, it just annoys me to have a comma at the beginning of a line, because basically, look at the shape of the comma. It angles off to the left. It angles off to where you were writing from. So if you have this comma here, it just looks off. I'm sorry, it just really does, and it really throws me off. So I can't do leading commas. I'm sorry if people came here looking for SQL with leading commas. Sorry to disappoint you. We will be using trailing commas. So yeah, we're just gonna, we don't even need an alias for this, but I'm just gonna do it for posterity. And what we do need to do here, however, is we need to group by the base. This basically just means, pun intended by the way, we need to have the base only be listed once because we're making an aggregate of something else in this same query. And so when I run that, I get these values. And I'm actually just going to paste these in here. Oh dear. Voila. I don't remember if I can do this. Yes, I can. So by holding the Option key, at least in the Apple case, you can actually drag down multiple lines, which is very helpful in this case. So I'm going to call this base counts, I don't know, base row counts. So we can see there's a pretty big discrepancy already just in the row counts. If we consider every row to be a pickup or a ride, however you want to call it, from this data set from Uber, then it's pretty crazy. I mean, this one has like, yeah, fifth or a sixth of what this base has. So obviously these bases are a little bit different, but that should make things interesting as well. So what other things can we do in our QA? We can start looking at not only how many values I have per base. That's just one thing. We also have lat long data, which I'll come to a little bit later. We can't really check the consistency of lat long data. We just have to sort of assume that it is correct lat long, that the formatting is correct and stuff like that. I just implicitly assume that formatting is okay in this data set because I did get it from Kaggle and other people have gone through it to make sure the formatting is okay. So I'm not going to do the really basic formatting checks. I'm just going to do like sort of my typical QA checks that I do. So what other things do I want to do? I definitely want to play a little bit more with this date time. And what do I mean by play? I'm going to show you. I don't know if you're like me, but I hate having date time formatted this way. I mean, for me, it's just not readable because there's very few countries in the world that use an imperial date time system where it is month, day, year. And that just really grinds my gears that this data set was provided in that way. I understand why it's provided that way, and I understand where the data set comes from, which is why it's that way, but it still annoys me. And in order to do some kind of checks about date time, if I was just going to run the same thing as before, as I did with the base, and I wanted to do this for date time, this wouldn't work. The main reason this doesn't work is because for this precise time, there will be very few records. And so if I want to figure out how many records there are per day or per month, I have to somehow split off this date time. So there's a couple different ways to do that. The easiest way that I see right now is to just extract whatever we need from this field. So we can use Postgres's extract function, and we're going to do extract, I don't know, month from date time. And this is like the pickup month, we're going to call that. And just to tell you, I need to do my sanity checks here to make sure that I'm not doing something wrong, like this. Date part unknown text does not exist. No function matches the given name and argument types. You might need to add explicit type casts. First error of the day, the real one. And that is because datetime is text formatted. How do we do this? We just make this into, I don't know, date for now. Might have to go with timestamp. Let's see if this worked. So it looks like it's worked. We can do a couple other tests to see if this works with, for example, day. Oh, should have renamed that. Sorry. There we go. So this looks like it's working. If this had been like more messed up, I would have had to first do the conversion to an actual date format with toDate, and basically say date time, and then put in all the formatting stuff, like, okay, this is month, or whatever, it's day, month, etc. Hi Oompa, welcome back. So we've actually gotten to the QA part that I was talking about earlier, about figuring out what this data set actually consists of before we go into sort of analysis stage. So we've just been working out date times. We've been converting this US or archaic system of month, day, year into something more formal and common, which is, well, yeah, at the moment just extracting months and days. So I actually will do something that I very often do, which is I just concatenate these two together. Concatenate just means sticking them together. And this is actually, it's a bit rough, to be honest. But I actually like doing this. This is too office job for me. Well, it is data analysis. I mean, you can spin it whatever way you want, but it's definitely data analysis. And it's either your cup of tea or it isn't. I mean, it's totally fine if you want to go check out something else. I am not offended at all. So yeah, I will concatenate things together. And in this case, for example, month, day, I'm just going to put a little dash in between. And then I actually have this pickup month, day, which it's not pretty, definitely not, but it allows me to do the following. It allows me to have month, day, and then count distinct. I don't even need to distinct, just count one. And basically, this is my row count. And the reason I'm doing it this way is I just want to have a better idea of how the data has moved per day. There we go. We can even do a little order by here to have a better idea. I always get confused about descending, ascending. Oh yeah, that was wrong. And we're gonna have problems with with this because yeah, this is what I meant about it being it's a bit of a sort of rough way of doing this. Oompa, a hobby like this would be great for a job. It's actually my job, so yeah, it's a little bit. Someone asked me the other day if like I do this as a hobby, and I said, well, both. It is my hobby as well as my job. So you might think it's crazy to be spending Wednesday evening or the 23rd of December actually doing this kind of stuff, but that's what I enjoy doing, and so I'm happy to share it with the world. And if other people are here to figure out if it's something for them or they want to learn something, then that's cool too. Hey, hello. Good to see you here. Didn't catch your stream before, unfortunately. Wanted to, but I was preparing for this massive undertaking. Okay, not massive undertaking. So what's the issue here with the extract function? The problem is that, of course, there's no... It's just putting one thing in, and it doesn't know context, so it doesn't know to put like a 0 in front of the 1 when I have the days. It just literally extracts the day itself. So if we wanted to do this super clean, we'd probably have to use toDate, which is a shame because I was hoping to do it this way, but it is not so clean. I would like to have sort of the order of 1 to 30 in there to make it a little bit easier to look at. So we are just going to go with month, oh sorry, single quotes here, month, day, year. This is like date formatted. I don't know if that's actually right. Let's find out. First we need to also put in the real date time and get rid of this. This should tell us if we've screwed up or not. Cody code codes. What are you specifically referring to, Oompa? I mean, this, at the moment, we're just formatting our date correctly because this date is rubbish for me. Because it's just, ugh, yeah, it's not readable. So at the moment, I'm only interested in the date. If I needed to, I would obviously take the time as well. But I don't need it right now. So let's just check. This seems like it's okay. Man, there's a lot of data, so actually I can't just scroll through. Sometimes you're able to just sort of go to the next page, right? So, do we have more pickups? We do. Okay, this seems like it's working. So, we are going to continue with our formatted date instead of this other rubbish that we had. Count 1, so row count. Now we have formatted date. We can actually just use a really cool function called date trunc. And date trunc, if I remember correctly, I always need to remember functions. So that's why I end up just Googling it, because, so this is text intervals. So we're going to do date trunc of this. That's basically my content. And the interval is, we want to truncate this to month, for example. Ooh, do I need to put this in single quotes perhaps? Let's see. And this is the, oh, not ride, pickup month. That's fun. Date trunc, date unknown does not exist. So it's having some issues with that not being cast. We might need to do this beforehand. Let's see. Maybe we need to just work with the data first. So we might need that common table expression after all that we were talking about. So let's call this time series, because that's what it is. Definitely don't need the count, but everything else. Don't need the order. So with time series as, and star from time series. So we now kids and dreams and code. My birth giver's mate said that dreaming in code was a lie. I think it's impossible to know because we obviously can't look into people's dreams. We just have to sort of take their word for it. But I think it's possible, personally. Alright, catch you around, Oompa. Thanks for joining. It's great having you here and active in the chat. If anyone else has questions or comments, feel free. I do like interacting with chat, which is why I'm streaming on Twitch as opposed to just putting up YouTube videos or something like that. The real-time interaction, I think, is interesting for both sides. So we have this to date, and this is the pickup date. and it is formatted, I believe. Let's just do a little test here. Yeah, so we have the pickup date. And if we want to truncate this, we should be able to just use date trunc, which would be the pickup date and month. And we call this pickup month. Why does that not work? Date unknown. Maybe it expects a timestamp. Gonna have to look this one up, guys. I don't remember why this one's not working. Sometimes the help in the editor is not enough. Date trunc. Oh, are you kidding me? It's the other way around. Yeah. That's a real bummer. Because probably we could have done it within the same. Oh yeah. Oh, that really blows. Because we can actually do this within this one. You know, because we can just basically go like that, comma, close that one off, and this is the pickup month. And this should work now. Yep. Yeah, that's one way of doing it. So basically what I've done, just to sort of explain that, I didn't really explain that too well now. I'm not interested in each day yet. I'm just interested in every month to see kind of how the months differ from each other. Because let's not forget, we had 6 months of data here. We figured out kind of the differences between the bases. So we saw there's some like separate row counts. And now I've just been working with the month. And you can see here that each date time here is just being truncated to month. Okay, it's a timestamp format, so it's just showing the 1st of April midnight, but it's basically just April. And now, because we have that, we can actually go ahead and we should, in my opinion, keep this as our raw date. So we're just going to call this date formatted. I don't think I need to cast this actually. Probably not. Cool. So we have a formatted date. And I could also use toTimestamp if I need the timestamp, but at the moment I'm not looking at the times, I'm just looking at the dates themselves first. And here is where I would actually use the date trunc. So, because then I'm able to, I'm able to just work with the kind of raw data here without changing anything. What I want to do here is I want to count how many pickups we have per month. And now we're going to group again. And now we will figure out, ooh, I forgot the distinct in here. That's not going to work. Oh, actually it didn't do too bad. So this is our monthly pickup data. So I'm also going to shove this in my temporary documentation here. I'm going to call this monthly row counts. And again, just going to have to comment this out. That's what happens when you write documentation in your code editor. And I'm going to get rid of this because we don't need it. Voila. So this is how the months differ. Interestingly enough, or rather not interestingly enough, it's increasing per month. It's something that we expected. Let's be honest. Uber was growing already in 2014. So it is expected that the number of pickups increase. But the number of pickups, the increase between each month is not linear. We can already see that. There's 55 to 64 here and then only to 65. I mean, I'm talking about 650,000 here, but I'm just looking at these numbers. And here they actually crack that 1 million ride or pickup, 1 million pickup mark sometime in September. Just in New York, by the way. So this is for those who have joined the stream maybe a little bit later, haven't been here from the very start. We are looking at a data set from Uber's pickups in New York City from April to September in 2014. And why are we doing that? Because we can. That's the reason. No, because it's fun to analyze data sets and show what is possible with SQL. I think it's something that is not so common or common knowledge about what is possible in sort of data analysis work. And it's hard for people to show what they do day to day because, well, it's confidential. The data that we work with, you know, data is the new oil, gold, diamond, whatever you want to call it. And so I think it's cool to just be able to show some stuff like with either COVID data like we did the last 2 times, or in this case Uber data. And if you do have ideas or suggestions of stuff to look at in the future, I'm happy to also do that on the stream for you guys. So what have we done here? Well, we're going to format that now because it looks nicer. We basically have figured out the distribution per month of the row counts, which are by definition in this case the pickups. Now we can start to think about what other checks we want to do. Do we want to see, for example, if every day exists that we expect to exist? That would be something interesting. So I expect there to be basically the number of days in this data set that I should see should be from the 1st of April to the end of September. So we're doing 30 plus 31 for May, plus 30 for June, plus 31 for July, plus 31 for August, plus 30 for September. And so I should see 183 days in this time series. How can I check this? Well, we can trunk this now to the day, pickup day. And instead of doing a count, we can give our computer a little break here. And we can leave the group by, it doesn't really matter. And I should get 183 rows. With this data set, it's definitely possible that there wasn't a pickup on a certain day, but it's very unlikely. With 4.4 million pickups in those months, as we can see, 183 rows. So this was one of the easiest checks to do when working with time series data, is the number of days there that you expect there to be. And the reality is, in this case, yes. So I'm quite happy about that. Would be dangerous if we were missing a few days. You could also plot this on a histogram, for example, just to see visually if you missed anything. And for that, you would have to actually have a full data set of all the days that you want. One way of doing that is with a function called generate series. So I can actually maybe do this here. I don't know, generate, let's call this series. Not Siri, nerd joke. So if I wanted to generate a series, then I can basically just have my data created for me. If I don't have a full data set, then I can use this generate series function. Just going to look up the exact format because I don't remember it off by heart, which you also don't need to because the internet is an amazing place where you can find all this stuff. Blah, blah, blah. So you can see other people using these date trunc functions. Generate series dates. Let's see a good one. Here's a good example. So, what does it look like? It looks like this. And basically it's what's from when until when with what interval. That's basically what I want. And Sharpclaw, interesting to see the process of building reports and data visualization. Yes, you have to do this. 80% of the time that you spend in reporting will be kind of data wrangling and data putting things together, and data cleansing and all these kinds of checks. Because if you give a report to a stakeholder and they ask a question and there's some underlying fundamental issue with the data, then that's really bad. And that's basically, as part of my job, that's what I have to be careful of. And so this generate series function allows you to actually generate a time series where you wouldn't be missing any days. You would have a full data set here. And then you could just join your time series data onto that, and then you could say, okay, yeah, for this data we don't have any, for this day we don't have any pickups or whatever. But fortunately, or unfortunately, in case of Uber's competition, Uber had pickups on every day of these months in 2014. And if we went back to, like, I don't know, 2011 or something, they might not have had that, but they did have on every day here. So yeah, that's easy check to do, very important check to do in my opinion. And now we're going to move on from this QA checks because they're pretty boring. So I just need to hydrate to keep my throat from going out on you. So let's see, what kind of things, so if we're confident now in this sort of QA of our data set, which I am, I now know we have all the days that we expect. I know how many rows I'm working with. I know that the numbers are a little bit different per month, all that kind of stuff. Now we can start to figure out what we actually want to look at. And as you know, with pure SQL, you can't actually visualize anything, which is fine. I mean, I have a table, you know, that's kind of a visualization, I guess. It sort of counts. It's not a great visualization, but yeah. So if I just output the entire data set that we have, let's limit, I don't know, 100, then this is what we're working with, right? Just to remind ourselves. And now, because I have the date formatted really nicely, I can also order by 1. And this will save me from having to click this column every time. So you saw it actually took a while for this to generate. It took 24 seconds that time. So 4.4 million rows, 24 seconds. As soon as we start running some kind of analytical stuff on this, it's really going to get messy. So we have to start filtering some data in here. So what I'm going to do is I'm actually going to just take a sample of this. And the way I'm going to do that is with the lat. And we can see that the lat here it's just a numeric. So we can say lat between 40.7188 or whatever and 41 point something like this. Now I don't know how much data we're going to get from this, but if it's just a small subset, Let's see how many rows we got. This just allows me to work with a smaller data set in the first place. 3.4 million, great. Okay, we need to restrict this a bit more. I'm not so familiar with lat/lon data, so that's probably a little bigger range than we intended. So this will be probably a little bit easier. Let's not forget that this is New York City, so of course this might be a pretty big range depending on how far across this actually is in real life. Oh yeah, I forgot to see, I actually ran the whole query here. I didn't really want to do that. Have a good night, Sharpclaw. Wishing you also very happy holidays. If you celebrate Christmas, Merry Christmas. Hope you enjoy the time. So let's see how much we've got here. Again, 3.4. Wow. Okay, this is kind of surprising. Didn't expect that much. Oh, I see. Okay, so it's actually a lot higher than I thought. So we're going to go with 7323. Before I run that entire query again, just going to run that subquery. Ah, there we go. That was quick. 700,000. That's decent. We're going to reduce it even more. I really just want, like, I don't know, 500 or something, but it seems to be 200,000. Yeah. Okay, I can live with that. So basically now, because I've done this quickly, you see this only took 1 second now. Because I've actually limited the initial kind of data frame, this is a lot easier to work with. And so this allows me to write my query, to do the things I need to do, and then when I'm ready, I can just comment this out and run it against the entire data set. And so it saves me time, literally. It will just save me a lot of time. So, what do we want to do now? I am interested to know about the spread of lat/lon based on the base. I don't think there's a better way to say that. What I mean is that I don't know much about the base, but I would like to put the lat/lon in relation to the base. So we have to think a little bit about what kind of numerical functions we can use to determine kind of the spread of lat/lon towards each base. So instead of actually working with this as a sort of time series at the moment, I'm just going to have the base as my kind of, I don't know, my first dimension. So TLC base, that was what it was called in the data set. TLC base company code affiliated with the Uber pickup. I don't really know what that really means, TLC, but it doesn't matter so much. So I'm going to use this TLC base as my kind of primary dimension, and then I'm going to have the latitude, and then I'm going to have the lon, which is the longitude, and this will give me, and then date formatted. Oh, why does it always do that? There we go. So this will give me basically the orientation of the data now towards my base as a primary dimension. And now we can think about some numerical functions rather than just like mapping this, which we of course will do. I will show you that in a second. We could look at kind of maybe the distance or something like that of each latitude, longitude, of like kind of the spread. Let's see. We could use something like a logarithmic function. I think there is a oh yeah, I would need, for earth distance, I would actually need to install a plugin, I think. Postgres. Yeah, I was hoping it would be built in. But it seems to be not the case. Earth distance? Oh really? Look at that. Ah, it's a module. Okay. I don't think it's in here. Earth. Nope. That would have been cool, but unfortunately it's not there. But yeah, that's actually a pretty neat thing. Oh wow, someone has done it with, good lord. Wow. Okay, this is interesting. I need to take a look at this. What is this code exactly? Square root of the first latitude longitude and the second. Wow, okay. I didn't know that was possible. Let's take a look here. So square root times cosine. This is just basic math here. So just take the documentation in here so I can figure this out. So lat lon is 0.1 and plat and plon is 0.2. Alright. So these are individual pickup locations. So the distance between each pickup is not that interesting. Distance from kind of a center point would be more interesting, but I don't have that. I don't have like a center point per base. I wonder if that's possible. Maybe we could compute like a central point. Center point lat lon. I wonder if that's possible. So you can't average them, obviously. Convert each of them, blah blah blah. Okay, this is pretty intense. Let's see if there's a SQL variant. ST-centroid with polygon stuff. Maybe there's a generic SQL approach. Otherwise we will just move on to something else, because that is beyond the scope of what I'm capable of doing in one stream. Location data types. I want to find the centroid. Interesting. Most easily done with raster calculations. Averaging the geos and weighting them by land area. Averaging is done using zonal statistics. Wow, that's pretty interesting. Okay. Then, wow. Yeah, face melting. Definitely a face melting answer. We're going to look at that some other time, because that's pretty advanced for me. So I'm going to just keep that for next time. But we can definitely do some basic things, like figure out the min-max per base. So the min latitude and the max latitude. I'm going to get tired of writing those, so I'm just going to abbreviate them. Min, lon, min lon and max lon. All right. Now, because we computed that, we should take out the date, and we should group by the base. Now we should have only 5 bases with each of their corresponding min and max values. So the minimum lat and the minimum lon are not the same. Latitude-wise, they are exactly identical, which is pretty funny. Didn't expect that to be the case. But longitude is not. I wonder why that is. So just to review, lat lon is just coordinates. So it's kind of interesting. I wonder why. It's not something I'm going to be able to answer, by the way. It's just something that I'm just talking out loud at this point about what I'm seeing. But basically these bases are, in terms of latitude, identical for whatever reason, but not in terms of longitude. So that's pretty interesting. I think, for whatever reason, that it's deliberate. It seems too coincidental to not be deliberate, but it's not something that we're really going to know. So I think we'll just leave it at that for now. What I wanted to show is how we can actually plot this with a visual solution, because I find lat lon data that's like a great example of something that you should really be able to visualize. Now I can't visualize in here. There's no way for me to like integrate a map or something like that. Well, maybe there is with some kind of module, but I find it pretty easy to just attach this to something called Metabase. And I'm also running Metabase in a Docker instance. And basically that just means that I can run it in my browser, like a normal browser window. And it's just opening localhost, right? So what I want to do is actually visualize, let's say these 5 data points. It's not super interesting. And what I can do, because Metabase is actually very powerful, I can actually use SQL in Metabase. So you're surely wondering, okay, why have I been writing all this SQL in here? Well, I like to build up also the excitement in the stream. So that's the reason I've been doing that. Technically speaking, I could just directly write SQL in Metabase and not work with this at all. Now that I have this full data set, I can actually go to my Metabase here. I'm just going to synchronize it to make sure that everything is up to date. There we go. And now what I can do is just go here, write SQL, Postgres, and I'm in. So what do is I'll just copy this. And yeah, what do I get? The same thing we had before. The difference being, okay, this is not in a dark theme, so sorry about that. But the difference being, the real difference being, I have visualization options. Now, none of these really make sense except the map in this case. And this is kind of cool. So if I do a pin map, I have a latitude, which is the min lat, and longitude, which is min lon. And I actually get a live map of New York. So this is pretty nifty. And as we can see, we have 1, 2, 3, 4, 5 data points. So these are the mins. Now let's do the same with the max. So this is kind of interesting. Wow, okay. So, so it was somewhere over here in terms of minimum and somewhere over there in terms of maximum. So min lat, min long. Interesting. So I would probably want to combine both together, but yeah, I don't need to do that. What else we can do, and surely you're going to see this coming, is we can just plot all of the rides here. So lat is just latitude, latitude. Lon is longitude. So I have to refresh here. Oh yeah, I have to run my query first. Oh, ouch. Yeah, I don't need to group anymore. So now it's running everything. And if I put lat and long in here, I should get all the pins on the map. Okay. I don't see them. Could it be too many values? I suppose it's possible. Let's go to visualization table. Okay, so we have a lot of values in here. Let's limit it. Let's limit to 1,000. So run. Let's go back to the visual map. Interesting. Okay. It's interesting that it's not displaying the pins. I would have thought that it would just work out of the box. But maybe there's something more to this. Oh yeah. Well, I don't know, let's try with 10. Maybe there's a pin limit that I don't know about. Ah, here we go. So there is a pin limit. We just didn't know about it. So here are the pins. So this is pretty nifty. There's a lot of things we could do here. We could probably group them in some way, and then kind of, yeah, we would have sort of aggregate counts per location, per area. And one way we can do that is with this grid map. And we have to do a kind of binned longitude, latitude. So we actually have to look that up because I've never done it before. But we're going to see what that means. So what does this mean? Blah, blah, blah. What does this even mean? I don't even know what that works. Blah, blah, blah. Double precision. Cannot group by latitude with binning when the coordinates are southwest. Okay. Field type. Oh, I see. There's even, I didn't know that. Data model. Oh yeah, latitude, longitude. Okay. That's weird. This is 23 days ago. Oh, so this is an issue with Metabase, unfortunately. I see. I see. That's unfortunate. So we would have to... How do I bin into ranges? Maybe we can try binning it. Ah, subtotal. Metabase should bin that for you automatically. 10, 50, or 100 bins if auto binning isn't blah blah blah. Yeah, so it seems to be a bug with Metabase that we're not able to do that because it would have been cool to actually bin them. Because I think there is like this summary. Yeah. Oh, look at that. 0.1, 1. Okay, so let's bin it every 10 degrees. And let's bin this one every 10 degrees. Oh, okay. So that's too much. 1 degree. Interesting. Alright, still too much. 0.1, 0.1. Alright. Oh wow, so everything is really dense. Visualization. So this is now auto-binned. We could technically export this and then re-import it and visualize that, but that's not so interesting. Let's visualize this as a area plot. Interesting. Yeah, it's not... Oh, wait a second. No. Didn't like that. Unfortunately. That's a shame. I was looking forward to doing it that way. But that's just one use case. We have some other use cases. Besides just min-max stuff. I'm curious about the spread of the date times. What do I mean by spread? I actually want to know if the pickups are all within similar time ranges. So one way of doing that is by defining ranges and saying, so this is, we're going to scrap this idea of lat-long for now. One way of doing that is by just looking at the time ranges and then categorizing them. So we have to be careful because here we actually truncated the time. Oh, maybe that's the reason. Oh, you know what? I think I just realized something. In our original query that we had this where lat-long filter, and that was probably messing with things a lot. That's why the min-max was also weird. Oh yeah. So that wasn't necessarily deliberate, huh? Might have just been fictitious. Or rather generated through the way that we generated the results here. That's unfortunate. Yeah, you see? This is actually not right. What we had before. That's why everything was kind of in the same place. That's unfortunate. Maybe we can check the binning. So min lat and max long. Funny. Okay. So these bases are a little bit different than before. Max lat and max long. Yeah. So obviously obviously there's some rides that go pretty far out. Pretty far out. Wow, that's crazy. It's actually super far. Did someone take an Uber all the way up to there? That must have cost a fortune. So we don't actually have the prices. Aha, this was a pickup, not a... Wow. What's here? Cracker Barrel. Wow. So maybe they went to eat. I digress. So actually, yeah, I'm interested in this date spread. And what do I mean by that? I mean, do all the pickups happen at the same time over the course of the months, or does it start to shift? And so we have to be a bit careful because we actually truncated this date. We took out the timestamp, and I don't want to do that anymore. Now I need the time, so we have to do to timestamp. And how do we do that? Well, it's the same. We just have to denote the formatting of the original timestamp. So we have this original date time, and so it's 0, which is HMMSS, I believe. Oh, it doesn't like that. Let's check the format for that. I don't always remember everything off by heart, so I'm gonna just look that up. Let's see here. To timestamp format. Yay! Okay. All right, so it's, yeah, I didn't realize. We actually have to use MI for minutes. 23 is invalid for 12-hour clock. Oh yeah, okay. 24-hour would be HH24. And let's see if that's worked. This might take another 20 seconds like before. Ah, no, it didn't. So to timestamp seems good to me. Wonderful. So now we have a full timestamp that we can work with. And now we can start to, use this sort of binning methodology to categorize them. So we're going to call this pickup time. Now I want to bin this. The way that I can bin is using case when. So case when X, then Y is basically the format, and then it's, else if I want to have an else condition, and then end, and I'm going to call this time category, or maybe I'll just call it time of day. All right. What are the common ways that we could do this? We could do 4, 4, 4, 4 would be 3 times 4 is 12. So we could do blocks of 4. What do we want to do? Blocks of 6. Basically 24 hours, right? So we can do 3-hour blocks. Be interesting. Maybe let's keep it granular. So let's do 3-hour blocks for now. So we're going to be doing when, and we're going to test this with 1 first, just to make sure it works all right. And then we can run it on the full data set. So when pickup time between Oh, maybe we can just pick the hour out of this. Actually, that's a cool idea. Let's do it this way. So let's extract the hour from the pickup time, and it's between 0 and 3. I'm going to call this late night. We're going to call this early morning, else other. Oh yeah, we need to wrap this in single quotes. Let's see what we get here. Oh, sorry, I wanted to include the other stuff just to make sure that what I'm doing is correct, because I want to see the original times in here. Take a drink while this is running. For anyone who's here watching who wasn't here from the beginning, we are looking at some data from Uber from 2014 about all of the pickups. It's about 4.4 million pickups, I believe 4.4, yeah. So we have these early morning clusters here. This is good. Seems to be working well. So let's continue with that. What else are we going to have? We're going to have 0 and 3. Then we're going to have between. So technically we're going with 4 and 6 would be. No, that's not right. 4 and 7. Because between considers the values in the lower and upper bounds included. So basically everything from midnight until 2:59:59, and then from 3 a.m. onwards it will be binned in this one. So we need to actually, no, sorry, 3, we need to actually check this for sure. This will be until 3:59:59. So these are 4-hour blocks, right? I'm going to keep it relatively granular. 4 and 7, 8 and 11. Then we're going to do, it is extracting 24 hours. So we're going to do 12, 13, 14. No, we have to sequential. 12 and 14. Then we have 15 and 18. Sorry, my my live coding is not that pretty today, I'm sorry. 19 and 21, and then 22, 2. Well, the last one will be 24, technically 0. So maybe we can just do greater than 22. So we're going to call this early morning. No. We'll call this dusk. No, dawn. Dawn, of course. Then we've got morning. Just morning. Then we've got lunch. Then we've got afternoon. Evening. And then night time. So now to figure out whether this is correct or not, I'm going to run this again, and I'm going to scroll through a few pages to see if it's annotating correctly for the pickup time. I could do this in a more efficient way by picking out certain times, but I can already see, so 15 afternoon, wonderful. This is cool. All right, And I'm gonna order, how do I want to order this? Oh boy. So I'm gonna do early morning. I'm just gonna prefix this so that I can order them by, yeah, chronologically. And then I'm just gonna do the first count here. Pickup count, group by 1. And let's see what comes up. This should be fairly interesting. This is running now the pickup times. Oh, this is interesting. Okay. So this is running the pickup times for every month, right? That's just every month, and that's fine. I will go into something I want to do in a second, which is a cohort analysis about whether this changes by month. But first we need to look at something, and that's this other. What is falling into the other segment? This is the question. Between 0 and 3, is it because of we need to figure this out. Because otherwise we don't know how to group our analysis. We don't know. Like, this other category has more than nighttime, which I find unlikely, let's say. So we need to figure out how it's binning these. So between, if I remember correctly, sorry for the shocking white, but I can't put Google into dark mode right now. Between low and high, greater than or equal to the low, less than or equal to the high. Between, so basically up until 3:59, blah blah blah, will be early morning, and then from 4 onwards, yeah, this is correct. So 3, 4, 7, 8, 11, 12, 14, 15, 18, 19, 21, 22. So the question is, what's in the other? Well, date time. What did we call it? Pickup time. Group by 1, order by 1. Where? Time of day. Now this is an issue because I can't use this. I can't use the definition of my case when in my where clause. The reason for that is because it's an aggregation type function, basically. I'll show you. See, where time of day equals other. And it's going to tell me syntax error. Oh, sorry. Time of day does not exist because it doesn't know it yet. Basically, at runtime, it's executing this in a way that it doesn't know what this is yet. So the way around that is either to write the condition out the way it is here, which is a huge pain in the arse, or to use the workaround way, which is to basically define another common table expression. So I'm going to get rid of this blinding me. We have the first CTE here, and then we can just make another one. We can say, I don't know, let's call this, who knows a good name for this? Feel free to slap it in the chat. What would we call this? So that's the time series, and then this is maybe formatted as, and then we are gonna block that, And then we can just do select from formatted. And now we've basically wrapped it again in another common table expression. So if I just close those, you can see what I mean. And now what we can do is say time of day and the pickup time. And the difference is here we can use Mere, nice to see you here. Great having you. And I said I would keep this stream in English, so you'll have to text in English. I'm fine, thank you. Hope you're well as well. It's getting close to Christmas, so I guess you're all ready for the celebrations over the next few days. We still need to put up our tree tomorrow. It's apparently always last minute. Nah, not fine, but it's okay. Well, if you need something, someone to talk to, then you know how to find me. No, we always put up our tree last minute. It's just the way it is. So what are we doing here? We wanted to basically find out what these others are, why there are so many being binned into this other category. So we can say where time of day pickup time formatted, and now we can say where time of day equals other. And you see here it knows this because we've wrapped it in this common table expression. Yeah, and of course I don't need the group by. So let's find out what's happening here. And I think I have a inkling of what it might be. I think it might be times that are invalid, but okay, this is just my feeling. Oh, that's interesting. So why hasn't it put these into nighttime? Greater than, oh, I see. Amateur mistake. We've forgotten to equalize also 22. These are basically all the pickups at 10. Oh wow, this is like, I was pretty sure that was the way to do it. There we go. So now we should have nothing binned in other anymore. As I was saying, I didn't expect there to be an other category. So this is one way of basically just sorting out my binning that I've been doing here with the case when. I shouldn't find any values. Perfect. So now we're in a good state. So now we can do what we did before, which is basically count 1, and this is my pickup count. 1, 2, pick up sticks. And we're just going to do star. And we do need to group this. Thank you very much for reminding me. Data grip. And now we will have our counts for each time of day, this section that we've posted. So it's pretty interesting. Of course, the way that we bin will affect the way that we analyze the data. This is a given. We need to be a little bit careful, right? Because we may draw some conclusions about lunchtime, but we need to be careful about how we do that. I'm just saying that the way that we've categorized it is just one way of doing it. We of course could have made 4 categories, right? Could have divided the day into 4 parts, but I want it to be relatively granular here. The reason I want it to be granular is because I want to see how this changes over time. So this is, again, this is every single month, but in one group. So these are all the rides, and I want to see, for example, because my hypothesis is that the rides that are happening in the evening nighttime, that those increased over the months. We saw that they increased by month anyway. The total number of rides per month increased. And so what do I need to do that? I need to bring in this other dimension in here, which is basically not only the classification of this, but I also need to bring in the month. How do I do that? With SQL, obviously. But how do I do that? I need to bring in this pickup time, but I need to classify it by month, and for that we're going to use the extract function again. I know, I'm really wringing it out for everything it's worth today. So we're going to do extract month from pickup time, and this is the pickup month. And you see now we've been able to work with two different pieces of information of the date time field within the same query, which is really cool. I think that's really great that we're able to do that without having to sort of wrangle the data in any way. Because we made everything nice and clean in the beginning, now we can work with it as we want. So we now have this. We need to insert another group by, because we now have pickup month and time of day in here. And if we do this, oh, I should probably order this. Let's order by 1 and 2 to keep things clean. And we should now get a table that shows us the month and the time of day with the pickup count. And at first glance, we probably won't be able to analyze this. You see? So this is the problem. At first glance, it's hard for me to see, okay, is this bigger than this? Is this bigger than this? And the distribution to the whole and that kind of stuff. So it would make sense to actually come up with some maybe percentages, just to be able to see, or we could visualize it. So let's do the visual route first, because that's the fast one. We're going to pop over to Metabase. I really wish this had a dark mode. I'm sorry that it does not. So again, we can just run this time series function in the SQL editor of Metabase directly. Good to hear that somebody is also okay with bright mode. Here we go. Now we have time of day, and now we can figure out what kind of visualization we want. Let's see what would fit to this. Maybe a combo chart. So we would want to have the x-axis as the pickup month, and the y-axis will be the... Oh, it's not letting me... That's interesting. Oh yeah, it doesn't like this. Okay, that's interesting. So I have to have the time of day on the x-axis for this point. That's fine. The y-axis is the pickup month and pickup count, but that's not working so well in this case, because you can see that it doesn't really know. Yeah, it's not really visualized well that I can see, is it increasing over the various months. So this is kind of the problem in a typical scenario. This is like the problem with data that's two-dimensional. So two-dimensional, not 2D, but with the pickup month and the time of day, I have 2 dimensions and then one aggregate, one metric. So I need to find a different visualization that fits. So we could look at, for example, an area. This might help us a little bit more. So x-axis, again, time of day. Y-axis, we could have the pickup month and then the pickup count. So if we just have the pickup count, and if we have, so these are the basically the number of pickups, right, by time of day for the entire series. Now we can actually add this month as a breakout. So now each month is traversing its own path, if that makes sense. So we can see here April, And now I'm not happy with the display of this. So let's see here if we can stack it. I think this is not bad. If we stack at 100%, maybe we can see if things are changing. So this is not bad. So pickup month 9, we can see that the strongest month in terms of variance looks like the summer. May, June, July. It's kind of interesting. So it has bin these also in percentages for me. It's done that based on the counts. But we could actually do this ourselves as well. So this visualization, it helps, but it's not getting me where I want to go. Maybe something like a scatter would help. So we've got pickup count with the y-axis, time of day, maybe by month. That doesn't make a lot of sense. Let's see what we can do here. The bubble size should be the count. That makes sense, because then we have the size of the bubble is determinate. But I mean, this is also the issue, right? Because the rides in proportion to each other might be larger, but of course in its respective month it might not be. So this is what I was saying, is that maybe it makes sense to also do this within each month itself. Now how do we do that? We do that by basically saying, let's come up with the metric of each month. So this is the pickup count for each month in total, right? But it's already for each category because we have this time of day dimension in there. So actually what we can do is count before that. Before we start categorizing, we can already count each month's pickups to then derive a percentage for each month. And the way that we could do that is we just have another common table expression. So we'll do monthly pickup counts. Let's call it monthly pickups. So with each common table expression, you add a comma, and then you need to, obviously we'll need to, work with it later. We'll need to join it or something like that, but that's no problem. And we're going to do the same thing here. We're going to extract the pickup month. Yeah, sorry, this is probably a little bit confusing. We obviously need to select first. Also, the formatting here is a bit weird. Select extract from time series. So we can actually kind of use the same base multiple times, right? We can call different functions or do different kinds of things with the same base table or data frame that we have here, and then bring them later, we can bring them back together again. So it kind of like diverge a little bit like a tree, and then you can bring it back together like a tree trunk, which I think is also really useful thing about common table expressions, is that they're kind of disjointed from one another. They don't need to be connected. So like this one and this one, they're not connected in any way yet, but they can connect later for some other purpose. And this is what we're going to be doing, right? We're going to say pickup month, and then we're going to do a count 1, and this is our total. Let's call this the monthly pickup. And so this we're going to call the just pickup count is fine, and this is our monthly pickups. So if I were to now just execute this query, I'm only going to get the stuff from this formatted, because I haven't included this time series. But I've done something important first, which is this pickup month. I have made sure that these are going to be the same because I'm going to join them together. So I'm going to take my monthly pickups. I'm going to call this A. We talked about table names earlier. This is just me being not very creative because it's getting late here. And I'm going to join the formatted table, or maybe we should call this time binned. I think it's a cooler name. And let's call this as B. So B dot pickup month is the same as A dot pickup month. And this is great. It allows us to now, basically, if we want to execute now, oh yeah, we'd have to obviously group by. I always forget group bys, by the way. It's just something that's going to happen, and I've come to terms with it. I just get that error every time, and it's just something you're going to have to live with if you watch this stream in the future. And basically, you see we have this pickups per month. I can make this distinct. We don't need multiple values here. And I will have this total monthly pickup value. And then I have this pickup count for each of my individual time frames. So what I can then do is basically say A dot pickup month. I only need one of them. Then I want to have the time of day. And then I want to have the pickup count, but I also want the, what do we call it? Monthly pickups. And so now, what I should get, hopefully, might need to slap another distinct in there. Here we go. So I have 556,767 pickups in April. So I have that for every single row in April, and I have the pickup count. And now, you've guessed it, we can just do B dot pickup count divided by A dot monthly pickups. And in order to get this to be an integer, not an integer, in order to get this to be a decimal, we're just going to float it. And this will give us a percentage, essentially, between 0 and 1, of what percentage each monthly's pickup is. Oh, we should call this percent monthly share. Great column name. And you see here, basically, if I were to add all of these together, it would equal 1. I'm just trusting it here, just roughly 5.051121. Let's make sure that actually adds up. Oh, it doesn't like that. Let's do it the other way. If you don't know about the shortcut sheet.new, Mary, I'm glad you're very impressed with this, judging from your emoji at least. We can just insert this. Oh, sum of 1. Look at that. So sheet.new just starts a new Google spreadsheet. You can use it for the other stuff too, like slides.new, docs.new, etc. Fast way to start up a new file. And so we see we have this percentage now for each month. And this is where we can use this in the visualization rather than relying on kind of two-dimensional categorization of the pickup count or something like that. We can just go back to our metabase, slap this in here, run it, doing science stuff. And because this is local, again, it's just so fast, which I really like. It might be having issues with the visualization because we actually didn't change that. That's fine. Let's see what this looks like. Let's go to so table, this is what we have. This per monthly share is what we're looking at. So we have a pickup month, time of day, and per monthly share. Again, 2 dimensions and 1 metric, but a little bit easier to work with. Combo. Here we go. X-axis, time of day, pickup month. Y-axis, not the count, the monthly share. And here we go. This is where we start to see stuff. So I don't like this combo chart. Let's go with a bar chart. Ugh, why is it doing this? I don't understand. I'm not so familiar with Metabase yet. Row, time of day. That's fun. I do have time to learn it. I mean, this is also, for me, it's a learning journey. Everything I show here is, I don't know necessarily everything that I'm showing. So it's also a journey for me, which is why I appreciate if people are patient. So let's take the per monthly share, the time of day on the x-axis, and the pickup month on the y-axis. That doesn't do a lot for me. Bubble size. I don't like this one. Let's try with an area, might be easier. Time of day and pickup month, and then the y-axis could be the share. And we see, of course, if we do this the same way, right? The share is the same as before. It's not any different, but because we have this percentage in here, right here, because we have that percentage, we can probably try to visualize this differently. I'm just looking for what options we have. So maybe just a simple bar. These are not bars, really. If I stack, I don't want to stack. So, y-axis doesn't really work so well. We'll just use the linear because we have percentage data, so it's always between 0 and 1 anyway. Axis. We could actually give a custom range, but because everything is within the same range, or within this very small range rather, nothing has a larger than 25% share. So this is kind of what I was going for. It's maybe not perfect, but it's what I was going for. I would maybe like to have it, instead of bar, I would like to have rows, but that's somehow not working. I'm not sure why that is. Yeah, we'll just go back to the bar chart for now. And so basically, if I take these months, and okay, I could obviously label these months, like with case when and stuff like that. In this final thing, case when for, then April, etc. But that's beyond the point. Basically, what I wanted to see, which my hypothesis was that the share of these evening rides is changing over time. And we have everything organized so that it is always April, May, June, July, August, September. And my hypothesis is not true. And we can see that. We can actually see the share of afternoon rides declined. It went down a little bit. It's obviously 3% of 4.4 million rides, or 3% of the total monthly pickups, which is 556,767, right? We're talking about moving at 3%. So we're talking about 16,000 rides. It's still a large amount, even in a city like New York, of those rides going to some other time of day, right? in terms of shifting percentages. But basically, from this sort of time of day analysis, we don't see a distinctive pattern other than the things are relatively the same, at least in this time space of April to September. We basically don't see any distinctive pattern, at least for me. I don't see a distinctive pattern. If you see something, feel free to note it down in the chat. I'm happy to also look into that. For me, I don't see something that says, oh, you know, they were increasing their share of morning rides. Yes, they were to some extent, but it's sort of plateaued here these 4 months. Again, this is seasonal data. So we're only looking at a short snapshot in time of these 6 months. We assume the data quality is good, but we don't know for sure, obviously. And I think this is like a good place to also sort of end today and draw some sort of initial conclusions about that. I would say there's two things. One, we could do a lot more with the lat long data, but actually someone beat me to the punch. So if you weren't here in the beginning, I went into detail about how I went over, let's say, how Todd actually did this amazing post analyzing 1.1 billion trips. So not only data from 2014, 2015, they actually expanded it to 2016, 2018 data. And there's even this live dashboard, which is absolutely incredible in terms of data viz and in terms of seeing what's happening. I mean, here with the pandemic, you can just see March, 66,000 rides, unique vehicles per month, and then boom, it just plummets, right, as people are going home and not taking those rides anymore. And you can see the amount of trips. Like Uber was doing 540,000 trips just in New York in February. And in March it went to 300,000, and in April it plummeted to 100,000. So 1/5 of what they, let's say, normally would have done. I think this kind of thing is fascinating, and obviously what we did today doesn't go into that kind of detail. I was more focused on maybe finding something based on time patterns. So I was looking at these different time bins. I would have liked to do something more with the lat long. So that's the first thing, is the lat long. I think there's more to be had from that. I mean, Todd also went into detail about weather based on that, which I think is amazing. They even did an analysis of Die Hard with a Vengeance, about making it from Upper West Side to Wall Street in 30 minutes, which is really cool. I really like Die Hard movies, so this was very entertaining about them analyzing it. And they did the thing about weather, about late night, they basically made some conclusions also about avoiding certain districts at late night as well. So they went into a lot more detail than we were able to do here in this sort of 2.5 hour session, obviously. So that's the first thing, is I think there's a lot more potential in this kind of data set. And the second thing I would say is that don't let your knowledge of this kind of thing stop you. A lot of people are just beginning in their sort of data analysis journey. While I've been doing this for some time, I'm still learning every day. As you saw, I was today struggling in a lot of cases, a lot of places, and I don't have any problem with that. I think it's very important to keep learning, and that's why I'm also doing these streams, to help people ask questions and see maybe how someone else would do something. And there's a couple other people on Twitch that are doing sort of data related streams, but there's very few, and so I wanted to help that along, because I think there's a lot to be learned about this field. I think it's very foreign to a lot of people about what data analysis is about and what reporting is about, and so I wanted to just showcase that a little bit more. So if you do have ideas or things you'd like to see, things you're interested about, a data set that you have access to that you wouldn't mind sharing, that I can show in the stream, then do send it my way. You'll find my contact details in my Twitch profile, and hope you all have a safe holidays. I don't know if I'll be streaming next week. Maybe. Let's see. Depends on my mood and how things are going with work, etc. But there may be time for a stream next week. In the meantime, enjoy the time that you have. Spend it well, and wish you all happy holidays. And if we don't see each other in time for another stream this year, then also a good start to the new year. So that's it. Thanks. Bye-bye.